The phase rule by Josiah Willard Gibbs, represented by Group 12. Biodata: Josiah Willard Gibbs was born on 11 February 1839. Background: Josiah Willard Gibbs, an American theoretical physicist and chemist, is widely considered one of the greatest scientists of the 19th century. Fun fact: Josiah Willard Gibbs laid to the theoretical foundation for physical chemistry and modern physics. He won the Nobel of his day twice. The first American PhD in engineering. Major contribution: developed the Gibbs free energy equation, introduced the concept of chemical potential, formulated the phase rule, paved the way for phase diagram and chemical equilibrium studies.
Moving on to the definition, we know that phase rule is developed by Josiah Willard Gibbs, which explains how phases, components, and degree of freedom actually relates to the system at equilibrium. And it shows that how many variables, like temperature or pressure, can change without affecting the number of phases. From the equation, it is mathematically written as F equals to C minus P plus 2, and for system that is at constant temperature, it becomes F equals to C minus P plus 1.
Engineers understand how material behave under different conditions. In metallurgical engineering, it explains the iron-carbon phase diagram, helping control the strength and hardness of steel and cast iron. In natural gas and petroleum engineering, it predicts gas, liquid, and solid behavior to prevent hydrate formation and design better separator. And the triple point of water perfectly show equilibrium, where ice, liquid, and vapor coexist at 0.01 degrees Celsius as 611.657 Pascal used to calibrate thermometers and define the Kelvin scale.
So we know that the importance is where the Gibbs work foundation actually for modern thermodynamics and chemical engineering, helping us predict the equilibrium and design the process like distillation and also the crystallization.
Gibbs' phase rule explains the relationship between phases, component, and variable in a system at equilibrium. The formula is F equal to C minus P plus 2, where F is the degree of freedom, C is the number of components, and P is the number of phases. This rule helps us identify how many conditions can change without disturbing equilibrium. For example, at the triple point of water, where solid, liquid, and vapor all coexist, F becomes 0, meaning both temperature and pressure are fixed. In conclusion, Josiah Willard Gibbs contributed greatly to modern thermodynamics. His ideas, including the phase rule and Gibbs free energy, are still used today in chemical engineering to design process and understand material behavior under different conditions. So here is the list of references that we used while preparing this topic.
So before we end, here's the 3D model illustrate on how phases and components interact visually, making the phase rule more easier to understand.
Thank you!